Hey, 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 you are watching the Cloud and DevOps Dead Days, and I'm happy to welcome you on this conference. And while all people around the world are trying to keep the social distance and stay home, you have this a great opportunity to attend online conference and to stay safe. So without any additional words, let me pass the microphone to Oleg Kasyan, who know a lot of how to build the data lake from scratch. Oleg, how are you today?
I'm fine, thank you. And I hope everyone here is also okay while we're staying home. So I guess I can say a few words about myself. So as you already mentioned, my name is Oleg Kasyan. I'm a systems architect, and I've been working on building data lake for the last year, and I have gained a lot of experience in this topic, and I want to share it, obviously. So, guess we can start. So, main question here is why? Why do we want to know about data lake? So you might know that the amount of data around the world, it is growing. It is growing constantly with a year. So we might say that currently we are about at 40 zettabytes of data being stored in the world. This is just like an open data from Google and other sources, but zettabytes. Could you imagine this amount of data? I actually had to Google what is zettabyte for that. So yeah, so 1 zettabyte is 1,000 etabytes, which is 1,000 petabytes, which is 1,000 terabytes. So it's just a huge amount of data. And with modern technologies, it comes to mind that this data should not be only stored somewhere, it should be processed. And with more companies adopting such processes like AI and machine learning, this data can be used currently. So in past, there were like a lot of data that you wouldn't use in your companies that you would just discard, but currently every piece of data is valuable. So you definitely want to work with this data. And it turned out some time ago that there's no solution for such big amount of data, for working with such big amount of data. Obviously, all the data that your company has. So why is it important? You may see that, yeah, like 12 years, 20 years ago, the amount of data was much less than it is now. You can say that the average size of IgG unit storage that you could go and just buy was like around 40 gigabytes in year 2001, but currently you can buy 10 terabytes per one unit. And we might say that the size of units of storage units is growing. So it means that not only the companies are storing more data, your own data volume also grows. So, and what is general approach to working for working with data, which was adopted earlier in the company? So obviously, in past, we could say that you would go and build data warehouse where you would store your like structured data. You have some operational databases, and then through some process you will send this data to one big database, SQL database, which is called data warehouse. And then you could use it for reporting, for analytics, for visualization, whatever your needs are. But you know, limitations of this approach is that this is only for structured data, and with an amount of this data growing, this big data warehouse database, it should also grow in size. And as we all know that SQL databases, they do not scale well horizontally. So you should scale it up, and you should give it more processing power at some point. You wouldn't be able to, because you wouldn't be able to give it like 200 cores and then give it 400 cores. It's just ridiculous. So we need to scale horizontally. And if we go to the problem, why keeping this data? So the storage cost, it is decreasing. I would say that with every year, you can see the prices for cloud storages decreasing. You can see the prices for storage units that you can buy on the market. They are also decreasing. But the data variety that we want to keep, it is growing, because previously, as I said, it is only structured data. It is only some data from databases that you could work with. But currently, when we are adopting AI and machine learning, the value of this data is growing, and the variety of this data is also growing. But of course, the volume of this data is also growing, and it means that you have to pay maybe more than you paid before, because if you want to keep all this data, the amount is bigger, and even since the storage cost is decreasing, the overall price for working with data, it is increasing. But okay, so as I mentioned earlier, we have a data warehouse approach, which could definitely suit some of our needs. We can work with structured data, but we can't horizontally scale it. We can't like just drop in new database and say, okay, we had one database, we now have two databases, and it just works okay. But still, data warehouse is a good approach. I'm not saying that we can replace it with data lake, but let's go into the data lake and say, what is data lake? So data lake is something that you could use for storing like all the data that you have. So you don't necessarily want to store the structured data, but you can store all the data that you have. So in my mind, the overall structure of data lake can be defined as 3 layers that we work with. And the first is the ingestion layer. So you obviously have some SQL databases, maybe you have some NoSQL databases, maybe you have some raw files like images, audio files, documents. You also might have some data that is persisted in some operational systems like Kafka, maybe Kinesis or something else. You probably rely on some third-party APIs, and you also want to keep this data for the future. Then you need to ingest this data somewhere, and to ingest this data, here comes storage layer, something that would hold this amount of data. And currently, there are a lot of file systems and storage approaches that could suit. I would say that everything starts with Hadoop, with HDFS, and then if you go into cloud, you could use Azure's data lake storage for that. If you go to AWS, you could use S3, and in Google, you would probably use cloud storage or some other approaches. And then when you have this data ingested somehow into your storage layer, you definitely want to work with this data. So for that, I say we have query layer. So you can find in some sources it been called like presentation layer or visualization layer, but you definitely want something that could query this large amount of data, this data with which differs in variety. So yeah, there are a lot of approaches in that. So we have Hive, which works on top of Hadoop. We have MapReduce, which could also be used to find the data which is stored in the storage layer. We have Presto from Facebook, which is a very nice engine. And what it can do, it can just go to multiple sources, collect the data from there, pre-process this data, and then aggregate. And it gives us SQL on top of that. So you can work with Presto like with SQL database using some database connection approaches. But what it would give you, it would just go through all the data and then make some distributed queries over all the data. And in Amazon, we have Athena, which is actually built on top of Presto, so it uses Presto underneath, and it is also a good service. And then we have Spark SQL. So Spark SQL is also something that can be used to get this data from your data lake storage. Then in Azure, we have Data Lake Analytics, and in Google, we have BigQuery. I will explain what tools you can specifically use in each of the public clouds a little bit later. But right now, what is data lake? Yeah, so data lake is something that is actually really simple. You have the storage layer, you have ingestion layer, and you have query layer. So you want to store big amount of data. You want to ingest all your data in the storage layer, and you want to have something that can be used to query this data. So it's just as simple as that. How can we use data lakes? So the most used and the most frequently applied approach is using the data lake for artificial intelligence and machine learning, because if you just want to work with some structured data and maybe do reporting, maybe data warehouse is just enough for you, because why not just put in all your structured data in the data warehouse? But if you have some images, if you have some text files, if you want to apply natural language processing, for example, to those data, so you definitely want to apply artificial intelligence and machine learning, and for that, the best approach of storing this and accessing this data is data lake. Then we can also use advanced analytics, and this is the part which was previously mostly handled by data warehouse. And we could also use data lake to provide the data for data warehouse. So it doesn't mean that we don't want to have data warehouse. Data warehouse is a good approach, and in most cases, you would say that if you have data lake, you would also have data warehouse. But data warehouse in this case, it wouldn't be something that is built on top of your operational databases, but it is built on top of data lake. And you can pre-process some data in data lake and then put it in data warehouse. You can decrease in this way the amount of data which is needed for data warehouse. So this part, the advanced analytics, it can be even handled on the data lake, and you might not need to use data warehouse for that. For ETL, you can use also data lake if you want to pre-process some data, as I mentioned. Also reporting, which is most cases handled by data warehouse, but in some cases you would go with data lake. The problem with data lake in this case is that it most of the time, it doesn't provide you a good latency on your queries, because data warehouse is something built on top of SQL approach, and it would give you fast queries, while data lake, it would have to traverse all the data, and if you have more of it, it would definitely take longer than getting this data from the data warehouse. But if you are okay with having long queries, you can use it for reporting. Also, you can use for ad hoc search, and this is something that you use when you want to analyze the data that you have, but you don't want to do it on some schedule. For example, you had some problem you had some incident and you are investigating this incident, and you might say that all the logs from all the systems are in the data lake, and you might want to find this data from the logs, from historical logs, and for that you can use some ad hoc search. So build some temporary ETL job that would just go into data lake, reverse all the data, and find the pieces that you need. Then what are the benefits? So benefits, in comparison to data warehouse, you can actually store all the unstructured data, and it is this perfect source of data for data warehouse. So you don't need to put the same data in data lake and the same data to data warehouse. You can actually grab the data and preprocess it and then put it to data warehouse and work with preprocessed data for reporting or in analytics or whatever. And as I mentioned, yeah, some data warehouse workloads can be shifted from data lake to data warehouse to data lake. And then, yeah, it is obviously a good place to store the data that you have, but you don't want to work with at the moment. So you might have some pictures, some files that you are not sure if you want to keep, but you could just put them into data lake, and maybe in the future you could use them. But it leads to some problems, of course. So yeah, so main problem is that it is additional cost, because you will spend money for storage, you would spend money for compute resources, you would spend money for computers, for adding some compute resources to something that you already have, because you would, for example, you have the database and you want to ingest it to data lake, then you have to increase resources on the database instance, because you would have some replication going into data lake, and it is also additional resources. It also comes in development and maintenance cost, because if you work with a large amount of unstructured data, this is definitely something that can break at any moment, because a lot of things change when you work with data. A lot of new systems are developed, a lot of old systems are decommissioned, so you need to have a team working with that that will keep your data lake fresh. Then data lake can become something that often called data swamp, because as I mentioned earlier, you would put everything that you have in data lake. In this case, you could put a lot of data that you would never need. So yeah, in this case, it's just like a swamp that you're just putting all your data, and at some moment you realize that you have terabytes over terabytes of data that you don't actually know what is it and why would you even keep it. So it's just a problem that you, but again, if you have a good development and maintenance team, they would keep it fresh. So this problem is just solved by the second point. Okay, so let's jump into some blueprints, some designs that we can use for our data lakes. I would present my vision on how we can build data lakes in 3 clouds, which are Azure, AWS, and Google Cloud, and also on-premise. So the first one is, of course, on-premise. So for ingestion layer, things that you want to ingest, mostly this would be SQL databases and NoSQL databases. The easiest way and the best way to ingest them is to use Kafka, and then use some change data capture approach like Debezium to put the replication data from SQL and NoSQL databases into Kafka. Kafka has a good framework which is called Kafka Connect, which could actually has some connectors developed for that, which could go to SQL databases and NoSQL databases and grab the data from there. Then you have some files, you have some APIs that you want to work with, and you have some data that is not streamed that you want to work on a schedule. Like you want to go once per day and grab this data and then put it into data lake. And for that, the best thing you can do is to develop some Spark job, which would be executed on the schedule, which would grab files, which would grab some data from your APIs and put it into the data lake. And then for storage, the most obvious approach would be to use Hadoop HDFS. Right now, as a remark, most of query layer systems can work with S3 and with systems that support S3 protocols. So for example, if you are familiar with Minio, which is like something distributed file systems that emulates S3 protocol, it could also be used. Then Ceph also has S3 protocol support, so it also can be used as a storage layer for your data lake. And then for query layer, I would go with Presto for some structured data and with Hadoop MapReduce for some unstructured data. Also, you could go with Hive. It's just up to you, depending on the requirements. But yeah, these are most commonly used systems and the ones that I would probably use. And then the first cloud that I would like to talk about is AWS, and mostly because I built data lake on AWS myself, and I know a lot about those systems. So as in previous example, we still have 3 layers, and in all examples, I would just divide all the systems into 3 layers, and then we have Amazon Kinesis, which is something very, which is a very good substitute for Kafka. We could also use Kafka, but Kinesis comes with a thing that we called, with a service that is called Kinesis Firehose, and it has very good support for S3. It could ingest files from Kinesis to Amazon S3. Also, there is a service that is called AWS Glue, and it is something that you would use on most of the layers in the data lake in AWS if you are building a data lake in AWS. And it comes with a feature which is called AWS Glue Streaming, which could also be used to get the data from Kinesis or obviously any streaming source. It is a new feature, so yeah, it was introduced like half a year ago, and it still has some problems which are to be fixed. But you can skip Firehose and use Kinesis and AWS Glue Streaming to ingest some data that you have that you would like process instantly, like some replication streams from your databases and maybe other streams. Also, you could use it. I mean, AWS Glue. You could use it to have ETL jobs, which would go and process some data in the batches. So you can use it to grab some data from other sources like S3 in other accounts, like something that is stored somewhere in third-party systems, and then put it into S3. Data pipelines also could be used, but it's just something that is built on top of EMR, and it is configurable, and you could use it obviously to ingest some data from your databases and other places into S3. And AWS DMS, which is database migration service, is something that is often used to ingest data from your SQL databases, which might be RDS databases or something that you just host yourself and manage yourself. And it can also go here into Stream because it supports CDC, change data capture, but the cost of this service is pretty big. And it also has some problems inside of it, which Amazon constantly fixes. But as I said, the price of this solution, it is really, really big. So when considering using DMS, you should look very, very careful into prices. Then for storage layer, we have S3, and I don't put any other options here because yes, you can use your self-hosted HDFS or some other system, but again, why? If you have S3 and the price of the S3 is pretty low, and all the systems, as I mentioned earlier, which are on the query layer, they can use S3 as a storage layer. So it is supported everywhere. So yeah, just use it. Then for the query layer, also we have AWS Glue, which comes with a feature which is called Data Catalog, and which could be used by Amazon Athena, which is built on top of Presto to access files from S3 and to execute SQL queries to files which are stored in S3. So you don't need to ingest this data into database to make some SQL queries. You could just go through those files using Athena. But again, this is only for some structured data. And if you have unstructured data that you want to access, you would build some Spark jobs and maybe MapReduce jobs and host them on EMR. Then in Google Cloud, I reviewed the blueprints from Google that they suggest. Mostly on every layer, you could see here that we have BigQuery. And BigQuery is something that is just could be used to substitute data lake needs for the structured data. I mean, Google say it is data warehouse, but it can hold like a lot of data, and it doesn't have any problems with scaling. So if you only want to use this, if you only want to work with structured data, you would just go with BigQuery, and it would be okay because it can be used to capture the data, and it can be used to store the data, and it could be used to query the data. So obviously on every layer you can see BigQuery. But if you're going to build some streaming approach, like I said, in AWS you would use Kinesis, on premise you would use Kafka. So in Google Cloud you would use PubSub. And there are also multiple services in the batch. You could also use like GSUtil to and maybe cron on your instances to put the data into cloud storage and then to access it with BigQuery on Cloud Dataproc. But yeah, obviously everything that you want to do, you could do in Google Cloud with those services. But if you have structured data, I would obviously go with BigQuery for every layer. Then in Azure, this is very interesting because they have some services which are specifically designed for the data lake, and for storage layers they have Azure Data Lake Storage, which is designed specifically to work with data lake data. And you have Azure Data Factory, very interesting thing because it comes with some templates that you could use to build your data ingestion pipelines. And then we have Azure HD Insights, which could be used to host your ETL jobs. And then you also have Azure Blob Storage, and you could use it as a storage layer. And then on the presentation layer, we have Azure Data Lake Analytics. And you could also use Azure HD Insights to build your MapReduce and Spark jobs and to grab the data that is stored on the storage layer. Well, if you see here, we have like multiple options, and obviously the best one would be Azure Data Lake Storage because it's just designed for that. But the prices are no bigger than the Azure Blob Storage. So if choosing the solution for storage layer in Azure, just consider this one, the top one, the Azure Data Lake Storage. Well, it all comes to the problem. So as a systems engineer, what do I need to know to build data lake? If I was a systems engineer and I wanted to start in this area, or I got assigned to the project that has such requirements, so what would be the requirements for me? What should I know? So you should first, of course, get familiar with cloud storage solutions. So S3, cloud storage, Azure Data Lake Storage, anything that is used on your project. And of course, should get familiar with AGFS because it just defined the approach to all the systems, and it just de facto the reference approach for file system, for distributed file system, and something that you would see a lot of times when building data lake. Then you should learn about what ETL, which is extract transform load, is, because you will actually, even as a systems engineer, you would build those pipelines. So complex pipelines, you would probably get some developer teams working on that, but why not building some pipelines by yourself? It's just the part that systems engineer could handle and obviously do. And then when you write in ETL jobs, you would most of the time use Python. So learning Python is very good idea. Also, everything that works with AI and ML uses Python, so it is a good idea to learn anyway. And then why? So for what reason would you like to learn about all of those technologies that are used for data lake? I would say that the demand on the engineers that could work with data lake is growing, because I saw my multiple of my colleagues were assigned to projects which were actually building data lake during this year, and I see the demand on the market is growing, and this is why this is because more and more companies, they adopt this approach. So because if you have data, you obviously want to work with it, and if your competitors have data lake and you don't have data lake, you would want to have some, even just because your competitor does. But yeah, and then artificial intelligence and machine learning, it is everywhere right now, and I see it is a future, and you can't regret it. You will obviously be working with those technologies, even if you don't want. In some future, they would come to you, and you would have to. So if you want to stay fresh with new technology set, with a new technology stack, you would learn all those tools that they use to build data lake. And I would say, from my point of view, it is really fun to work with, because you would work with a lot of different things. You would work with a lot of different systems. You would try to integrate those systems. You would write some ETL jobs that would be used to integrate those systems. So it is fun. It is not something that you do like if you work for application support and you just have some systems that you have to maintain, but it is always something new, and it is always really, really interesting. So with that being said, I hope that you will consider learning those technologies, and then see you working on data lake projects. Yeah. And thank you very much. If you want to contact me, my name is Oleg Kasyan. You can find me on LinkedIn. You could also find me on GitHub. Don't hesitate to contact me, and I guess I'm ready to answer questions.
All right. Thank you, Oleg. It was very interesting speech, especially me get a lot of new information. And now we have the two questions from audience. And let's start from the one which has the particular name. This is the question from Mikhail, and he would like to know, would you suggest some exact cloud for the data lake, which is better? By speed, analytics, simplicity, or it depends only on your choice of the cloud provider itself?
Yeah, a good question. I would say that every cloud has a set of technologies which is required to build data lakes. So even if you don't have cloud and even if you do it on-prem, you still have technologies that are okay for that. So I would say that it only depends on the infrastructure that already exists. So if you have your infrastructure in Azure, so you would go with Azure. If you have infrastructure in AWS, you would go in with AWS. Because if you have infrastructure in AWS, why would you go with Azure? Because, for example, you have a lot of data and you would have to move this data from AWS to Azure. You would pay for moving this data. You would pay for network throughput. So why doing that? Just go with one that you have. Okay.
All right, thank you. And the second question, unfortunately, there is no name, but still the question is good. Is there any possibility the security issue when we use data lake? Is
Yes.
there any possible security issue when we use data lake?
Yes, yes. There is obviously a lot of security issues that could happen because you should be really careful when ingesting data into data lake, because you don't want some data that is considered like PII or some other data to be ingested into data lake and to be accessed. Some cloud providers even has solutions that would give you like fine-grained access to this data. For example, AWS, they recently introduced service which is called Lake Formation, where you can just configure which fields can be accessible by Asina. I mean, which fields in your S3 files could be accessed by Asina, which could be not accessed, and what user can access which tables and which fields. But as I said, you don't want to keep some secure data, some cardholder data in data lake, because yeah, it's just a really bad idea, because you would provide this data to everyone in your organization who works with data lake, and you don't want to.
All right, and we don't have any additional questions, at least right now at the online translation. So I would like to say thank you to Oleg for this very interesting speech. I also would like to say thank you to the audience for being active and asking the question. Oleg, can you nominate which question was the best from these two questions?
I would say the second one was really interesting because
second one.
Yeah.
The second one. All right. I'll ask the email address from the second guy. Hold on a second. We just got the few more questions. Hold on. And we still have the time to answer the questions. So guys,
Yeah,
please
okay.
stay tuned. All right. Let me publish both of them. So the first one from the Rajiv. What metrics can be used to monitor the health of data lake? Are there tools available for the monitoring and reporting of data health?
Yeah, a good question. So something that we actually did on my project, you could use all the tools, all the same tool sets that you have for monitoring for other approaches. So, but if you go with metrics, there are several things that you want to monitor. For example, you want to monitor how frequently your data is accessed, and you want to monitor how frequently your data changes. So if you see some huge amount of data being outgested from your data lake, and this is not something that actually happens like frequently, then you would go and make some security assessment for that, because you could say that your data is might be stolen or something bad happens to it. So data ingest, data outgest, and the overall volume change in your data lake, this is something that should be monitored. And also the access from users, like you want to monitor how many users accesses your data lake. This is not something that is just operational metric. I would say it has some business value, because if no one uses your data lake, maybe you want to reconsider the idea of even having one. So yeah, I would say yes, metrics which ingest, outgest, data volume, and the number of users that accesses your data lake and the frequency.
All right. So let me ask the next question. And the audience, you can still have the publish your question. We still have some time. Well, Oleg will be asking to the next one. So, have you ever used the Amazon Market for data security?
No, I haven't used Amazon Macy, but maybe it could be used. I'm not an expert with Macy, so can't really discuss this topic, but I would take a look. It's an interesting question. Yeah.
All right. So no new questions, So you can try to vote for the best question again, or to keep your previous decision.
Yes, I would like to keep my previous decision. Still, yeah, monitoring question is also really good, because it's something that you, it is a problem that you will work with. You would see this problem with metrics, because business always wants to see some metrics, and they want to understand if this is something that you want or you don't want to have. So yeah.
All right, so thank you guys. Thank you for this session again. And of course, you can continue to ask your questions offline after this session, and to put it into the portal. Let me share the link in the public chat. So you can just go to this link, ask your questions, and open the discussion with the speaker, and speaker will be happy to answer. And have a good day. See you on the next session, and stay safe. Wash your hands. Cheers.
Yeah.
Bye-bye.
Stay safe. Bye.